Sweet. All right. For the two and many people that will hopefully be joining us soon here, I'm Joe Blankenship, organizer Tampa Bay Data Engineering Group, and really glad that everybody could show up tonight. Once again, apologies for the schedule changes. It's been kind of chaotic, especially since Ian kind of threw a wrench in the works. So I'm glad that those of you who did show up can show up. So that being said, though, this will be a recorded event, so make sure to turn off videos and mics as needed, specifically mics. That way, we're not talking over the speaker. Um, and if you have any questions, there is Q&A inside chat, but then there's also the chat itself. So feel free to post questions in either other, and I'll try to make sure that Alex is aware of those questions as he goes along. But we'll likely handle questions at the end of the talk. But without further ado, I will introduce our speaker. Alex is a developer advocate for Dremio with a history of creating content to enable developers of all types through his personal projects like devnursery.com, the Web Dev 101 podcast, and the Data Nation podcast. Alex has been a developer with companies like Crossfield Digital, Campus Guard, GenEd Systems, and others, along with being an instructor for General Assembly boot camps. And tonight, he'll be presenting open source in the Lakehouse. Um, Without further ado, Alex, please take it away.
Hey everybody, and let me share my screen. So I want to share, let's share that, and let's head over to here, the presentation, go to the first slide, and let's begin the slideshow. Hey everybody, my name is again Alex Merced. I'm a developer advocate here at Dremio, particularly on the tech advocacy team, where basically what we focus on is really helping people in the data engineering space make them aware of these cutting edge open source technologies that really solve a lot of the challenges of yesterday and the challenges of tomorrow when it comes to the many aspects of architecting our data infrastructure. So today I'm here to talk about particularly like the whole idea of the data lakehouse, essentially, and then the role that open source plays in lakehouse. So open source and lakehouse. So particularly I'll be talking about like things like Apache Iceberg, Apache Arrow, Project Nessie. I'll also be talking about Apache Parquet. Um, and yeah, we're gonna have a fun time and go through a lot of really cool technologies. Okay. Bottom line is what I want to talk about today is again, first we're going to just kind of go over this idea of a data lakehouse. So what is a data lakehouse? I keep hearing all these buzzwords and marketing stuff about this whole data lakehouse thing. Is it really something different? Is it really something, a thing? Um, Let me go back. Oop, oops. Let me go back to the slideshow. I hit wrong button. There we go. Okay. We're also going to talk about why does open matter. So like at the end of the day, like there are platforms that call themselves a lake house with different degrees of openness. And why does that matter? What is Apache Iceberg? What is Apache Arrow? What is Project Nessie? What is Parquet? So let's start off with that question. What is a data lakehouse? So to appreciate the data lakehouse, we're gonna have to appreciate like the status quo. So like the way that generally the traditional data infrastructure. And again, the reason why the status quo has been is because up until recently, it was the best way to do things. It's just like there was just with the technology that was available, this was the way to do it. So generally, what would happen is you'd have like your OLTP data sources, your Postgres's, your MySQLs, and other places where data would come in, and some of it would be structured, some of it would be unstructured. So you needed a place that could handle structured and unstructured data and for the purpose of analysis. And that was the data lake. So we would just land all our data in maybe a giant Hadoop cluster, or we would land it in cloud storage on Amazon, Google Cloud, Azure. And then that was their data lake, and we would run some ad hoc jobs there. But really, it was just a place to put the stuff. And then what would happen is that when it came to our structured data, we would then do another ETL job. So basically, we had already paid for ETL, taking that data from data source to the data lake. We had already paid for storage to store the data in the data lake, but now we're going to be paying to ETL again to get that data from a subset of that data from the data lake to the data warehouse, where we're going to have to pay for storage for that data in the data warehouse. And the storage in the data warehouse was a bit more expensive than the storage in the data lake. And the other issue is like the way that the data was stored was generally in sort of a proprietary format. Essentially, you were putting your data in a box, and it works really well in that box. That box could analyze within the tools that that box provided you. You could do things performantly. You had all sorts of really good features, and people loved the box. Okay, but at the end of the day, your data was stuck in that box in proprietary formats. You may or may not be able to use a lot of your other favorite tools in the data inside the box. Okay, and then because stuff was inside the box in proprietary formats, proprietary storage, using proprietary engines, you had to pay a premium for that. It costed more. But again, at the same time, you're making all these duplicative copies because I made a copy of the data to the data lake. I made a copy of the data to the data warehouse. And now maybe I've made several copies among different data marts. And then maybe some of the analysts take an extract of that data and they've downloaded it as a CSV file that they're using in Tableau, but now that's another copy that's completely unaccounted for, and you just had this sort of like issue of like data drift. So you had all these issues. They were just kind of parcel with the territory. As data's complicated. You know, getting it right is complicated, and it's just a constant journey. But we had these problems. Again, data warehouses are those. A lot of times you go into it and you're like, okay, this bill's not so bad, but then over time, you start looking at that data warehouse bill and you're like, that's a big number. Again, proprietary components. So maybe you hear about all these cool new tools that offer you all sorts of features that you would like to try out, but you can't because your data's in the box and your box doesn't work with that new cool tool. Okay, and you had data drift. Again, all these sort of this big scatter of different copies of the same data over there, and you're wondering, hey, are people using, keeping all those copies in sync, and that whole deal. So the idea was, okay, well, one way we could solve that problem, we could reduce these costs if we did more of the kind of workloads we did on the data warehouse and the data lake. And this was tried in the past, okay, in the days of like the high days of Hadoop and Hive. I mean, that was the goal. Like, hey, let's do more on the data lake. Problem was, is it wasn't the easiest thing to do. It wasn't as performant as one would expect. There was a lot of different like technological barriers that just didn't make it practical to do yet. But technology has evolved, and a lot of those problems when it comes to ease of use, when it comes to performance, have been overcome. So now you can actually get that benefit of lower cost for moving a lot of your workloads on top of the data lake and having the kind of features you would expect from a data warehouse and be able to actually have those kind of features on a data lake. Okay, and that's the idea of a data lakehouse, where the idea is that you're going to have tool sets and technology that actually enables to kind of have that similar experience and a wider experience with features that don't exist on a data warehouse on your data lake storage. So essentially the new world would look like in a data lakehouse is you would still ETL the data from the data source to the data lake. The difference is that you're not going to go make an additional copy into a data warehouse. Instead, you would, when you ETL that data initially, you're going to land it inside a table format like Apache Iceberg. And then basically that format is going to allow several different possible tools to work with that data. And then you can just use the tool that works best for you. So, maybe Flink is the right tool for the job. Maybe Spark's the right tool for the job. Maybe Dremio is the right tool for the job. But the idea is you're not locked into any one tool, giving you a lot more flexibility. Again, that lower cost. And then particularly with Dremio is really built for the ease of use part. So it really kind of has this platform that kind of creates this like uniform uh, interface across all your data on top of just being a very performant query engine. So again, the ease of use, the performance, all these kind of things have been more overcome. Okay, because data lakes are inexpensive. Okay, Apache Iceberg is going to enable all those data warehouse features like ACID transactions, time travel, and then we'll talk about Project Nessie, which is going to enable things like multi-table transactions and other really cool stuff. And then again, these open formats are going to prevent that whole like price creep because you're going to have more competition. Okay, the idea being like now every aspect of the stack becomes more competitive. That keeps the price pressure down. And that's another reason why openness really matters because you want to keep that competition going. That's what keeps the price down because you don't have that lock-in. So it's much easier to say, okay, hey, my data's in Iceberg tables. I don't have to use this particular engine. I can switch engines whenever I want. And that creates a more open, competitive atmosphere that keeps your prices in check. So that way, over time, you don't end up in a data lakehouse that's just basically a glorified, expensive data warehouse. Again, why openness matters, not just the fact that you're doing the work on the data lake, it's also the aspect of openness that really brings you those benefits. Cool. But generally, when you think of a data warehouse, and particularly a open lakehouse, which again is just basically the idea of doing that work on the data lake, but really kind of focusing on using open source tools and open technologies that allow you to give you those options. So you can have that modularity to give you again that nice competitive pressure to keep prices down, but also give you the flexibility to use the tools that get the job done. The kind of components that come in there when you're architecting such a lakehouse are things like your storage layer, like where you're going to store the data. That's now the big innovation there that really kind of amped things was like cloud object storage. Okay, because running large on-prem Hadoop clusters, okay, again in the high days of Hadoop and Hive, that also wasn't very easy or practical to really make that the center of your data analyst world. So again, the reason why this data lakehouse thing that didn't come sooner was because the practicalities were different than they are now. So there's innovations in how we store data with cloud object storage. There's innovations with how we store the data in files with like Apache Parquet, okay, which allows any engine to be able to much more efficiently look through those files by having those row groups and those headers and footers that allow it to just more efficiently look through those files. Having a table format like Apache Iceberg that allows you to see the data that's stored um, and look at it as a table, not just a big sea of files, to allow you to interact with it like you interact with a table in a data warehouse or the way you interact with a table on a database. And particularly for like Iceberg centers around the idea of a catalog. There has to be a way that we track all these tables so that we know which tables are part of your. And for that, you have different options like Project Nessie, AWS Glue, Hive. These are all tools you can use to track your different tables in an Iceberg. And then you have different engines. Okay, so this could be something like Dremio, could be like a Spark, could be like a Flink. But again, you don't have to just settle on one. That's the beauty of an open lakehouse, that you can use the tool that's right for the thing that you're doing. Um, you're not trying to figure out how to make the thing that you're locked into work because that's what you're stuck with. Now, again, just kind of showing you like a sample architecture. Okay, so here, we're saying an example AWS storage. So let's say you're storing your data in S3, and generally all the files are like sitting in like Apache Parquet. Okay, and again, we will also use, let's say, Iceberg as our table format. And again, the benefit of Iceberg is things like ACID transactions. So you're gonna be able to actually now do, because before, yeah, you could query your data lake. Like you were able to like query your data lake pretty decently and do a lot of ad hoc queries, but it's different than actually doing like a lot of that last mile ETL work, doing your transforms, deleting stuff, upserts, updates. These kind of things weren't kind of things that were really associated with like workloads on the data lake. But table formats like Apache Iceberg make that possible. The ability to time travel, to be able to go back and query the data, query your table as it was at a previous point in time. Partition evolution, that's unique to Iceberg. The ability to actually change the way your table is partitioned without having to rewrite the table. So you might have a table that you partition by year, but as the data begins to grow, like let's say sales, and now you're getting more and more sales at a much quicker basis, and now you want to partition by month, that's just a quick metadata transaction. Doesn't require you to rewrite every data file just to change the way the table is partitioned. Same thing with schema evolution. It's just a metadata transaction in Iceberg. So you don't have to change every data file and rewrite every file just because you want to change your schema. Hidden partitioning, we'll get into that a little bit more later on, but it's essentially a feature that makes using partitioning a lot easier. So that way you don't have to write these large complex queries with a bunch of extra predicates just to take advantage of partitioning. Again, you can support multiple file formats. So Iceberg allows you to use Parquet, ORC, or Avro as the files in your table, while many of the other formats generally are just like Parquet only. But again, we need a catalog, and there's a catalog, something like a Project Nessie. And Project Nessie is like really, really cool. Like what it does, it enables a paradigm called data as code, which means you're gonna have the ability to like switch and merge branches. So imagine you're ETLing data. So you have data coming in from a streaming pipeline, and what you do is instead of having it land right there where all your other data consumers can just query it right off the bat, you can have it land in a branch, and then you just, you can do all your data quality checks as the data comes in, and then when you feel that the data is ready to go, you can just then merge that branch back into a main branch that all your data consumers are querying from. So it allows you to kind of isolate a lot of that ETL work, be able to more better do data quality checks, and even then roll back things because it tracks commits just like Git. So if you make a mistake and hey, like, oh, this query is not what I meant to do, you can literally just roll back to the previous commit and you're good to go. Okay, it's not a tragedy. So you can again isolate workloads. Allows you to kind of do work on multiple tables at the same time. So that's like a multi-table transaction. Like this is really cool because imagine, let's say you have like a fact table with like 4 dimension tables. If you update just one, um, problem is that someone joins those tables, they're going to get partially updated data, and that's not going to really work really well. But again, with Arctic, I can make a branch, update all 5 tables, and then merge the changes to all 5 tables as if it all happened at the same time. And it'll all so that way there is no you're either querying the old version or you're querying the new version, nothing in between. Um, so Arctic, the Nessie open source technology really does that. Arctic is just essentially Nessie as a service. So basically, instead of having to run your own Nessie server, you can use Arctic to get a cloud managed version of Nessie, which comes with a really nice UI. And then in the future, it's going to have like different like sort of data optimization features, ingestion features, really become the way sort of the centerpiece for you to, for all other engines, not just like Dremio, but like Spark, Flink, Presto, whatever, to be able to interact with your data in this sort of data as code paradigm. And again, all built on these open source technologies such as Apache Iceberg, Parquet, Nessie, and so forth. And then again, as an example, a Lakehouse engine like Dremio, which has an easy UI, a semantic layer, so you can actually organize how you distribute the data from Dremio. So basically, you've been hearing all this talk about like a metrics layer. Well, that's been a feature that's been sort of built into Dremio for years, known as the semantic layer. It has high performance because of technologies like Apache Arrow, one of the other open source technologies that we'll be talking about today, which is now getting all sorts of attention, mainly because of a project you might have heard of, DuckDB. Okay, DuckDB allows you, it's kind of like SQLite for data analytics, where you can basically run in a database in memory and just kind of connect some data sources and run really, really quick analytics on your local computer. And the reason it's able to provide you that performance is because of Apache Arrow. And Apache Arrow is a project that originated in a large part at Dremio. And basically, Dremio is built heavily with Apache Arrow when it's doing more more multi-processing, multi-node distributed type processing. But at the end of the day, you get that performance. So understanding, if you understand the benefits of DuckDB, then you understand the benefit that Arrow brings to Dremio. And some other technologies like C3, the cloud cache, and reflections, which are like auto refresh materializations. They're a little bit more complicated than that, but that's the gist. Um, Connects directly to BI tools, cloud managed service. Don't want to go too far down there. Okay, but again, the point is like you have this lakehouse, you can architect this lakehouse, and it has all sorts of really great features that make it easier, cost effective, um, so that way you can just focus, on things like data quality and executing in other areas. But why does the open part matter? Why does it matter that Apache Iceberg, Apache Arrow, Project Nessie, Apache Parquet, why does it matter that these things in particular are open source? One, innovation. Because if it's open source, you can have lots of people working on it. And there's an incentive for it's not just one company kind of directing the direction of it. And different companies who contribute to these projects. So if you go to Iceberg, I mean, you have like Netflix, you have Disney, you have Apple, who are using it or contributing to it, and they all have different interests. And because of that, that tug of war between, okay, hey, well, we're using Iceberg and we would really like it to go in this direction. Hey, we use Iceberg, we would like it to use in this direction. It creates this sort of momentum that of innovation because you have that broad ecosystem and also that broad diversity of developers in Iceberg. They're like all the people who develop Iceberg are not just from one company. They're from several companies. And that again allows for more innovation, a more robust discussion, robust transparency. The ecosystem. Okay, again, the fact that like Iceberg is as open as it is, you have a huge variety of tools that are embracing that because basically when there is no sort of one company that is in charge like of the thing, then what happens is that everyone feels like, hey, this is a fair playing field. Okay, so I can go build Iceberg functionality into my product. Okay, and I'm not at a disadvantage because somebody else controls that project. And I know I don't have to be of the fear that basically they can always put themselves at an advantage uh, because they control the project. Um, so you have this really nice sort of fair balanced ecosystem, which is why you're getting such momentum when you see like companies like Presto, Dremio, Snowflake, Cloudera, Amazon, all really making big pushes with Apache Iceberg this year. Again, just that being sort of like the biggest hyped example of all of these. So really, Arrow and Iceberg are getting a lot of hype. Arrow a lot because of one, DuckDB, its surge in popularity recently, and two, Iceberg, mainly because again you had this surge of just everybody getting behind and supporting Iceberg this year. Cost. Again, because there's competition, because there's an open playing field, and you have multiple vendors competing against each other, that puts price pressure because they know you're not locked in. If you're using Apache Iceberg, well, you can switch engines, you can switch tools whenever you like, as long as they support Iceberg, and that means they don't have that same pricing powers when they lock you in with like a data warehouse or lock you into something or into formats that are more proprietary. So it doesn't even have to be like a full-on box like a data warehouse. They could just be locking you onto technologies on your data lake that are still controlled by sort of one party, forcing you to kind of have to kind of buy into their set of tools, and then eventually giving them a lot of pricing power in the market, um, which means you end up in the same place in the long run. So that's the reason why like true openness matters. Not the fact that just that it's open code. Okay, that's good. We want open code and we want to be able to transparently see the code, but there should also be open and transparent contributions. It should be really easy to figure out who's contributing and where they're from. Okay, like and there should also be open and transparent governance. We should know who are on the committees that run these projects, be able to see like public communications. And these are all things you kind of see with like particularly like Iceberg, where actually with and Arrow, all the Apache projects, and that's the beauty of when a project has that Apache name next to it, because right there on the Apache website you can look up who is on the PMC committee to see who are the people voting on every commit in the direction of the project. They generally have an Apache run mailing list that's publicly readable, so you really do have like sort of that visibility into the project that gives you that sort of certainty that it's open. Okay, so the first project we'll talk about specifically is Apache Parquet. And Apache Parquet, basically you had a couple different problems. Like one is a lot of the formats of the past were in a lot of the databases and whatnot. Everything was very row based because traditionally that's the way you did things, because you generally were doing like transactional stuff. But as data analytics needs kept expanding and the size of data sets beginning, row based storage, row based formats were just like antiquated. So people started moving towards columnar because it just made more sense, because you're not grabbing one or two rows, you're oftentimes grabbing all the rows, but you only need one or two columns. So organizing the data in a columnar format made more sense. This is sort of like the fundamental insight of things like pandas and whatnot. But what happened is that everyone kept coming out with their own different columnar formats. So you would use one tool, it was columnar, but they did it their way. And then you would use another tool, they were columnar, and they would do it that way. So if you had interconnectivity between the tools, what would happen? Well, bottom line is you didn't have a central way to do it. And so basically when it came to files and the way you store files, okay, Apache Parquet gave you like a standard way. Like say, hey, you want to store data in a columnar format, okay, do it this way. And it was not only that it stored data in a columnar format, but there was metadata in those formats, and it was binary as well. It's not like a text-based format like a JSON or a CSV. It's in binary, which means it can store a lot more information in a lot less space. But in that binary is also a bunch of metadata that allows engines to read and be able to kind of like identify, like basically you're breaking up the data into row groups, and then within each row group you have like each column as a structure, and then I can see what the metadata of that row group is, and I can determine from the engine level, hey, do I need to read these rows? So then I can actually skip groups of rows as I read the files, instead of like your traditional files where they have to read the whole file up front and then do the work. So you could actually process and run queries on these files a lot faster. Okay, because it has all this kind of information that's stored in that file. Okay, then you have Apache Iceberg. Again, Apache Iceberg is a table format. This was sort of the response or the evolution from Hive. So you had Hive that allowed, again, Hive was originally created so that way writing MapReduce jobs weren't so hard back in the Hadoop days. Okay, instead of having to write a really complex MapReduce job using Java, I could just write an SQL statement in Hive, and then Hive would just translate that into a MapReduce job. But in order to do that, you need to have a table. Like you need to be able to recognize something as a table, and that's why Hive needed a format. And it basically said, hey, anything inside of a folder, that's a table. And that worked for its purposes at the time. But as the needs, the demands of what we wanted to do on the data lake grow, we needed something new, and this is where Apache Iceberg comes in. And what Apache Iceberg does is that it breaks away from that whole like what's inside the folder is the table. Instead, it stores metadata across like 3 tiers. So basically, you have a table-wide metadata that describes the table. These are called the metadata files, and they just kind of describe what the table is as a whole. Then you'll have several snapshots. So every time the table changes, you get a snapshot. And then generally each snapshot gets a manifest list. So that's a snapshot level metadata that describes that particular point in time. And then what's going to happen is that all the files are broken up into groups, and each those groups of files are called manifest files. So essentially a manifest list is a list of all the groups of files that make up the table at that point in time. But each of these layers has metadata that an engine can use to prune what they're looking at. So right here I can say, hey, I'm looking at the snapshot. And then when I look through the snapshot, it's listing all the different groups of files, and I can actually look at the metadata for each group and say, okay, I don't need to look at this group. I don't need to look at this group. I don't need to look at this group. So that way I'm eliminating big chunks of files from having to be considered. And then I go to these group files, the manifest files, and I can go look at the metadata for individual files and say, okay, I don't need to look at this file. I don't need to look at this file. So that way, by the time the engine actually goes to scan the data, you're not scanning petabytes and petabytes of data. You might be scanning a small fraction of that data because only a small fraction of the data actually applies to your query, giving you much faster performance. But also, again, you're breaking away from that file folder structure. So full files and folders don't have to be like all the files don't have to be in the same folder, which makes it a lot easier to migrate because you don't have to necessarily move a bunch of files into a folder to migrate. You can just say, okay, this file there, this file there, this file here. These are all part of my table. As long as it's listed in the metadata, you're good. Also allows you to avoid like throttling on object storage, because on object storage like S3, if you have too many files under the same prefix, which aka like the same folder, what happens is that too many requests, they can end up getting throttled. So it could end up slowing queries when you have really big partitions, because generally each partition would be under its own prefix. So what Apache Iceberg can do if you turn on the switch is that it will actually essentially shard those partitions into multiple prefixes that are hashed. Because it doesn't rely on the folder structure like Hive and other table formats, which also rely on that Hive-based structure. It can have those benefits that allow you to not only scale, but scale on object storage, which is really important because that's generally where things are going when it comes to storing your data in your data lakes. So again, we have those 3 categories: metadata files define the table, manifest lists define the groups, a snapshot, and then the manifests define the groups of files that make up a snapshot. And then that's generally how Iceberg works. Engines then read this metadata so they can scan the data on your data lake. Now, the benefits of Apache Iceberg is you get a better experience, like a much better experience over the traditional sort of data lake experience. Because again, you're abstracting the physical. You don't have to think about files in cloud storage. You're thinking about tables. Okay, and that's generally the way we naturally work. Okay, much easier for me to think, hey, there's a sales table, there's a staging table, and write SQL statements around it. And Apache Iceberg enables me to do that on the data lake. But it's also going to enable things that were really hard to do before, like concurrent reads and writes. Okay, hidden partitioning. So that's way like generally what would happen in the past is you'd have to create like additional columns for partitioning. So if I wanted to partition by like month, I'd have to create like a month column because the timestamp column wasn't sufficient. But Iceberg has some aspects to how it handles partitioning where you don't have to create extra columns just to partition by month or year. Okay, it has like these really smart partitioning rules. And the beauty of that is that someone who's consuming the table who wouldn't think to query a month column because they're already querying the timestamp column, they're still going to get the benefit of partitioning. They're not going to accidentally get a full table scan. They're going to get rich schema evolution support. So basically, you want to change the schema any way you want, you can do so with Apache Iceberg. Okay. Oh, 1 second. Let me go back. Oops, I did it again. Oops, I did it again. Okay. Bad joke. So, back to here. Okay. Again, basically what's happening is that on every write, the data is being like sort of rewritten. Not all the data, but like your metadata is being rewritten. And you can set up jobs to rewrite. It's not It's not like a service that's constantly optimizing your data, but you can set up sort of like cron jobs that trigger APIs that do things like compaction or whatnot. Okay, and then change data capture is something that is coming to Iceberg that they just started working on. So that'll be something that'll be there, and it'll make it a lot easier to handle change data capture on the data lake. Okay, basically, but you're gonna get higher performance with Apache Iceberg because again, it has the metadata that allows you to accelerate performance. Okay, also updates. When it comes to like row level updates, like I want to update a few records, I want to delete a few records, that can be really difficult in the data lake. Like how do you do that? And oftentimes, like by default, you use what's called a copy on write strategy, where basically if I have to update one row in a file, I'm going to rewrite that whole file minus that one row. And that's the default in Iceberg. Like if you don't specify otherwise, that's what it'll do. But you also have the option of merge on read. And not only can you switch to merge on read, where instead of rewriting the whole file, it's just going to keep that file and write a delete file that tracks which record was deleted. And then you reconcile that on read. Not only can you do that, you can specify when it does that. So you can say, hey, only updates merge on read and keep deletes copy on write. Like you have that kind of granular control over the behavior of your table versus just setting it at a table level. Okay, you have enhanced cost-based optimization because you're tracking statistics in Iceberg on every write. So all that metadata has like statistics that it tracks on every write. Less data to read because again, you're pruning those files as you go through the layers of metadata. And again, you get the benefits of the scalability on object storage. But another really cool project that I mentioned earlier, again, becoming a big topic of conversation because it's one of the big things that really like allows something like DuckDB to be as exciting as it's been for everybody recently, is Apache Arrow. Okay, and what Apache Arrow is, it's kind of like what Parquet was. So like Parquet was a binary file format for how we store data in a file in a columnar way. But here's the thing, when we open the file, like in any program, that data then has to be loaded into memory for processing. So if I don't load it into a columnar format to be processed, I'm still going to run into slowdown. And again, software would do that. Software would load it in a columnar format, but everyone did it differently. So then when you were shipping data from program to program, there was a lot of serialization because I would have to convert your type of columnar to my type of columnar or convert row-based data to columnar. Like there's all this like conversion and serialization and deserialization as you move data back and forth. And that really slowed things down. So the idea was to have a standard format. We all work from the same playbook of how we represent columnar data in memory for processing. Okay, and not only does this provide you less deserialization and deserialization between tools, which means tools can communicate a lot faster, but also it's going to allow you just to process things faster because there's also some optimizations that are also included with Apache Arrow. Okay, and Apache Arrow, the project not only has the standard format, but they work on libraries in pretty much like most of the main languages, like I think like 12 or 13 languages that they have libraries for. So if you want to work with Apache Arrow in Python, you can work with Apache Arrow in Python. You want to work with Apache Arrow in Go, you can. You want to work with Apache Arrow in Rust, you can. There are libraries so that way you can incorporate that format. Okay, and essentially the application for Apache Arrows again when you're doing like computation things and whatnot. Again, support for many languages. It was co-created by Dremio and Wes McKinney. It actually like it started out pretty much as Dremio's in-memory format in the early days, and then just kind of evolved from there. In a sense, that was like part of the software, and then eventually like, okay, well, everyone should use this. Rapid adoption, popularity, like again, this is becoming super popular nowadays. I mean, now I think just heard that like Snowflake is doing adding Apache Arrow support to some of their tooling. So more and more tools are adding that Apache Arrow so that way you can get that performance, that benefit. So you can see like all sorts of different companies that are really getting behind that Arrow bandwagon. Okay, you can kind of see like how the number of downloads on PyPy per month has really accelerated. But again, that increase in performance is one of those things that was needed in order to make a data lakehouse more practical. So having that table format, okay, and that open table format, and this open in-memory columnar format, these are things that solve the things that made it hard to make the data lake the center of your analytical world in the past, along with like cloud storage. So all these things are just kind of coalescing right now and really making this whole idea of a data lakehouse actually quite practical and quite worth it. But the Arrow project is made up of a lot of also sub projects that complement it. So now we know we can have the data represented in this uniform way. Okay, but what about moving it back and forth? So basically, what if, like, for example, you are writing a Python script on your computer and you want to request data from Dremio and you want to do it as fast as possible? Okay, that's where Arrow Flight comes in. Arrow Flight is a standard way for moving data back and forth. Okay, because in the past, what you would use is JDBC, ODBC. And if you've used JDBC, ODBC, what's the experience like? You want to connect to a new data source, and now you got to go find the drivers for that data source, and then you got to go configure the drivers, which might involve you writing some ini files. Not the most pleasant experience. Okay, once it's all set up, life's all good, but then you run into another issue. Dremio, again, is handling the data in columnar format, and then you're probably going to go load it into a pandas data frame and work with it in columnar. But JDBC, ODBC transports data in a row-based format. So you end up having the slowdown because every time Dremio is sending columnar data, JDBC, ODBC has to turn it to a row-based format, and then at the other end on your Python script, you're turning it back into a columnar format. So you're just doing sort of extra work. So wouldn't it be ideal if you just kind of kept it columnar the whole way through? And that's what Aeroflight does. It allows you to transfer the data as the original format. So you save all that serialization and deserialization time, and you get huge speed benefits. Like, there's a video I put on YouTube where I did a PyODBC versus Arrow, and it was like basically it's a minute long video because it took a minute for PyODBC to like get the data, and it was like if you watch the video, it's like 10 seconds in, like Arrow's done, and it's for a fairly large amount of data, and it just gets faster the more data you throw at it, like the difference. Okay, but it's essentially a general purpose framework built around RPC type APIs, but it's basically designed for data in a modern world. And what we mean by that is that when you think of JDBC and ODBC, it was designed for a world where basically you had one client and one server. So I'm saying, okay, my computer is asking your computer for information. Okay, so bottom line, in today's world, where we're doing things with multiple huge clusters of computers to process things, that would mean that basically that cluster would have to coalesce all that data onto like one of those nodes and then send that over. Okay, and that's not, why can't I just go grab it directly from each individual node? Okay, so this Apache Arrow Flight is also designed to enable that. So again, it's column oriented. Again, because of the format, it's binary, it's highly compressed. But again, it makes the client side distributing easier, because the way the API works is, what's going on under the hood is that you will send your query, and then what happens is you get back a ticket, like you basically kind of like a ticket to a ride, or a theme park, and then you can go to each node and say, hey, I'm looking for the data from this query. Here's my ticket, and then that each node could provide you with their portion directly of that query, which means you're saving the time of having to wait for these 10 computers to go coalesce all the data over here. They can just be sending you the pieces as they are ready, and you will just collect that data even faster. Like that kind of implementation of Arrow is still something that's kind of like, the technology's there, but I don't think there's been that much distributed implementation of Arrow yet in that shape. But these are the kind of things that it enables, and you'll be seeing in the future, which will again even be further performance enhancements. Okay, again, that's also part of like the whole parallel data transfers thing. And just to kind of show you some examples, again, the more records you're talking about, the bigger the difference. So see, when you're talking about like 2,000 records, ODBC is, like the difference is not that much. Now when we go to 5 million records, it's a huge difference. You're talking about like almost a minute for ODBC versus like maybe a couple seconds for flight. And then you go to 1 billion records, again, it becomes pretty stark. It's still only a few seconds for flight. Like you'll notice like the difference in time doesn't change all that much. Again, the reason is because where a lot of that time is being spent is in the deserialization and serialization between columnar and row-based data every time you move the data. Cool. And then Aeroflight SQL essentially is going to be this, like, the idea is to have a single client. Okay, so it's this client server protocol that allows you to, makes it much easier to use the transfer protocol. So Aeroflight, the transfer protocol, Aeroflight SQL is this framework for saying you only have one client. So imagine that world. Imagine that world where You want to use a different database? You don't have to download a new client, and you don't have to download any drivers. That's the way Aeroflight works. So as they build the Aeroflight SQL library for each of those like 12 languages, what's going to happen is that I could go use Aeroflight in Python, and if I'm pulling data from Dremio, I just use Aeroflight. If I'm pulling data from, let's say through DuckDB, I just use Aeroflight, Aeroflight SQL, and because they'll support it. And in this case, I'm not downloading different, I don't have to worry about configuring drivers or downloading different clients and learning the syntax for different clients. It's just one library, one set of rules, one set of functions that works across all your data sources and transfers that data source really quickly. Okay, which again will just also just make everyone's life in general much easier. But of course, even though it's like a one uniform transfer protocol, which is again the goal here to kind of again create something that's faster but also more uniform and something we can all agree on. Okay, and open format. And again, leverages the performance across SQL. So again, you can just use SQL and it's all kind of standardized. But the other point I want to make is there is the difficulty when it comes to adoption because people, even though once you learn Flight SQL, it's the same rules for every database that supports it. That's like another thing you have to learn. So what Dremio has recently done and contributed to the open source community is an ODBC and JDBC driver. So basically, you can install this ODBC JDBC driver from Dremio. That's now part of the open source. So it's now just it's a thing. It's out there. But you can use and take advantage of Aeroflight SQL, like take advantage of Aeroflight things like Dremio, DuckDB, anything that has that functionality built in. And you can just use JDBC. You just use the same ODBC you've been used to. Like you don't have to change the way you're doing things because the driver does all that stuff under the hood. Essentially, like it makes the ability to adopt Aeroflight into your workflow much easier because you don't have to do anything different. You download one driver, and again, that driver will work for all Aeroflight supporting endpoints. So literally, like the last ODBC driver you'll have to download. Again, as more and more tools support Aeroflight. Okay, but again, it's going to allow you to kind of set up those connections. It basically just allows you to use Aeroflight using JDBC ODBC. And that's really nice because again, if you've downloaded many and configured many ODBC and JDBC drivers, it is not fun. Okay, and it's now completely open source. Then there's Project Nessie. This one I've been doing some writing the last few days on this, and it's just an exciting topic. The kind of things you can do and that are possible and going to be possible with this. But essentially, again, you start off with like columnar formats that were multi-engine, they were scalable, fast queries. So that was one. And again, basically what we're seeing here is like the evolution of the data lake, like the technologies that made things more practical to do more and more in the data lake. So first it was like the file formats like Apache Parquet. Then it was like the open table formats like Apache Iceberg and like Delta Lake that made it possible to read and write. It allowed you to really kind of work with schemas and partitions on your data lake, do more data optimization. And now the next sort of like the next frontier is data as code. So this is the whole idea of being able to have like Git-like functionality on your data lake. Be able to say, okay, I'm going to branch a table. Okay, and there's different versions of this. So like for example, the Iceberg format is actually building table level branching into it. So that's something that will come down the road in the Apache Iceberg table format. Project Nessie does versioning at the catalog level. So what you're doing is you're creating versions of essentially what you're doing is you're creating different versions. What it's tracking it's not tracking the versions of all your files. It's tracking all the versions of the metadata of your tables, essentially. And the benefit of that is that you basically when you're doing it at the catalog level, when you make a branch, that includes all your tables. So that means I can make a branch and do those multi-table transactions. That's the difference between doing it sort of like again at a table level versus a catalog level. I can say, okay, hey, I want to make a branch, make a change to like 5 tables, those are all commits to the same branch, and then I merge it, and now all those transactions across all those tables have been committed at the same time and made live to my data consumers at the same time. And again, there's like other projects that do it at like the file level. Okay. And again, the difference is like what are the amount of changes you have to track. Like if you're tracking the changes in individual files, that's a lot more changes. So it affects like throughput. Like Nessie was really designed to to try to have the maximum throughput possible for like data type workloads, for like high intensity data workloads. They actually did explore when they were like the original developers. They were like thinking, okay, hey, we want to do something like this. They first see, hey, is Git practical? Like, why don't we just use Git? Does it work? But problem is like Git's throughput isn't fast enough because it's tracking the diffs of like individual files. So this way they went to catalog level. So again, it's built to scale. Um, and again, the cool thing about doing it at the table level is also you can use SQL. So you can actually express a lot of this like Git-like semantics in your SQL, saying like create branch, merge branch statements, which is nice because at the end of the day, like we oftentimes like to write SQL over having to write Python or Java. Like oftentimes it's just a nice SQL statement. It's much easier. So if I can do the thing in SQL, that's always going to kind of put a smile on my face. Okay, and again, just kind of reiterating the same thing. So we're seeing like the advancements, and the idea is like that when all these pieces are in place, so essentially what happens, every engine communicates with the catalog. And then the catalog, which would be Nessie, tells them where the tables are. And again, the tables are made up of generally Apache Parquet files. And so like this makes data lakes very performant. They make it where really it is now possible to substitute your data warehouse with a data lake as it wasn't necessarily before. So like these open source technologies, which is again the fundamental point here, have transformed what is possible. But the reality is that it is possible today to really kind of take your data, to have a data lakehouse, to really kind of replace your data warehouse with a data lakehouse. But again, to get the full benefit of it, you want it to be open. You want to really rely and lean into those open source technologies for the reasons I mentioned earlier. Okay, but again, what we're seeing in this slide is again all the engines, they talk to the catalog. But again, Nessie provides that Git-like semantics where you can have branches, so you can actually have multiple branches of the same of your catalog, which allows you to kind of like work on your tables in isolation. So I can have changes that I'm making to the table that other people can't query, and then I can, as an engineer, once I feel like they're ready to go, publish them. And this is oftentimes referred to as like the write audit publish platform or pattern. Okay, I like to sometimes call it the branch audit merge pattern, because if it's more specifically if you're using Nessie, you're creating a branch, you're going to do all your data quality checks, your audits, and then you're going to merge that branch back in. But ideas here, you still have like your iceberg metadata files. It's all good. Okay, so again, the benefits of kind of having that data as code methodologies, again, you can isolate the changes. So again, I can ETL onto a branch, which gives me time, so I don't have to like sit there and like get a bunch of emails that the data is like corrupt in the morning. I can just be like, okay, the data's landed. Let me go double check. See everything looks good. Looks good. Merge it in. Okay, so I can isolate that work. I can do version control. So maybe you might want different versions of the data for different reasons, and then I can create branches to experiment. So maybe I wanted to experiment with some schema changes or experiment with some things. I can create a branch in my catalog, apply those experiments, and then if we like the result of those experiments, I can merge them in. Okay. So again, you can, and then again, you have the ability to also like roll back to previous commits and things like that if you make a mistake. Governance. Okay. You can set access rules in Nessie. So that way you can control like who access the data, but in the future that's going to become more and more robust. So that way, basically, this can provide you sort of a universal, like your catalog will be the universal place where all your rules are. So that way, no matter whether it's Spark, whether it's Flink, whether it's Dremio, whatever engine, all your governance rules and all your security rules are being honored because they're all connected to this catalog that has all those rules baked in. Okay, so it just becomes the heart of everything. Okay, and again, kind of reiterating that whole multi-table transaction idea. You could do this in a data warehouse, right? Like that was a thing that you could do. You can do these kind of transactions in a data warehouse up till now, but not on a data lake. The only problem with a data warehouse is you have to do it in one session with one user with SQL only. Okay, so it would look something like this. You would begin a transaction, and then you would do all these other transactions, and then you would commit the transaction. And essentially would do all this and then commit it at the end. That's great. Wonderful. But with Nessie, now you can do multiple sessions, multiple users, multiple engines and services because you get to decide when the merge happens. So you can create a branch. So I'll just create a branch called ETL. We might have some ingestion coming in from Kafka. We doing some ingestion of services. Maybe do some transformations in Spark. Do some other transformations in Dremio. And these might be different people doing this work from different tools all simultaneously. And all these different jobs are happening. And then when they're all done, we just switch back to our main branch and merge in our ETL branch. And then all those changes appear simultaneously. And those were not just changes in one set of transactions that happened at one time. These might have been transactions that occurred over an hour from multiple people working across multiple technologies. And that's just something that was not possible before. Nessie makes that possible. Okay, and again, Nessie's built to work with like all engines. So you can see here, like with Dremio, your statements would kind of look like this. If you're working with like Spark, okay, your Spark SQL statements would kind of look like this. If you're working with your create branch, using the branch, switching over to the branch, doing your work. If you're using Flink, same idea. Again, basic bottom line is like it's built to be open in the same way that Apache Iceberg is built to be open, in the same way that Arrow is open. Because the idea is that if the entire industry sort of like adopts, like embraces these technologies, it's to everyone's benefit. Okay, because it's going to allow us to do that much more with the data lake, which is going to allow us to solve all those problems we mentioned at the beginning. Or I don't want to say necessarily problems, but let's say things that could be improved upon as far as our traditional workflow. Because a traditional workflow is a traditional workflow because it was the best way to do things with what we have. But now we have new technology that makes new better things possible. Okay. Now, if you want to learn more about these technologies, like basically that's what me and the tech advocacy team do. Our job is to learn about these technologies, eat, sleep, and breathe these technologies, and write articles that you can find over there at dremio.com/subsurface. You can find all our articles there. You can follow me on Twitter at amdatalakehouse. So again, that's amdatalakehouse on Twitter. I try to post a lot of content, images, blogs, videos. I do some Twitter spaces here and there. I try to be very, very screaming from the hilltops, embrace Iceberg, Arrow, Nessie, because these technologies, the more people who use them in production, the more tools that incorporate them into their tool sets. Again, the bigger the value proposition, far as like cost savings, performance, whatnot, when all these things are embraced. So it'll make everyone's life better essentially. And with that, we'll open it up to questions and answers. But again, thank you very much again, Tampa Bay Data Engineers Group, for having me again, and hopefully again in the future.
No, it's been an absolute pleasure, man. We did have one question, which I think is actually right up your alley since you are the Dremio rep. So,
Mm-hmm. Sounds
so
good.
Mike asked if Dremio is a Databricks competitor, and if so, let's see, how does usability compare between Dremio and Databricks, if there is comparability there?
I mean, it depends on the particular. Like, basically, like there's lots of different services that Databricks offers, and there's a lot of services that Dremio offers. So it depends on which particular tools. But I would say, like, it depends. It depends on your use case. When it comes to Databricks, like you're gonna be best off with Databricks when you're using like the Delta Lake table format. You're gonna get sort of the best experience on the Databricks platform that way. The problem then becomes, though, is that the Delta Lake table format is very much, controlled by Databricks. Okay, I mean, multiple times they've said they've open sourced it and made it kind of a celebration for it multiple times. Um, but at the end of the day, like, you still can't see who's on the technical steering committee. Um, and there's just sort of still certain people are still finding features that are sort of like Databricks only when it's kind of marketed as a Delta Lake thing. Which is fine if you're using Delta Lake with Databricks. But then again, the bigger issues you can run into that lock-in. With Dremio, everything is kind of open in the sense that, like, if you're using, let's say Dremio has the Dremio Arctic catalog, which is essentially Nessie as a service. If you use that and you don't want to use Dremio Sonar, the engine, that's fine. You can use Arctic, Spark, you can use Presto, you can use whatever. We're not going to let you say, hey, you can use the service, and we're not going to kind of build it in a way that's going to prevent you from using whatever tool you like. Same thing with like the Dremio Sonar engine. we don't just query iceberg tables. Like the Dremio query engine can also query Delta Lake tables, because if you like Delta Lake, you should be able to query your Delta Lake tables with it. We try not to, like our mantra is, we want you to have access to all your data, and we want everyone else to have, we want you to be able to access the data the way you want. Like, and that's generally like one of the feedback we get from a lot of people who switch or like start using Dremio, is what they liked is they didn't have to change so much about what they do. It's like now they have to learn the Dremio way of doing things. Generally, Dremio is flexible enough that there's ways that we recommend to do things, but you can generally keep doing the things the way you've been doing them. Keep your data sources, keep your data where you've been keeping it, and still get a lot of the benefits. So, for example, let's say you don't want to use a table format at all, and you just want to keep your data in a Postgres database. You could do that. You can actually connect a Postgres database to Dremio, and then you can use features like data reflections, that really kind of help make it really practical to do sort of like data virtualization type strategies like that. So there's a lot of different like use cases where the way I would think about it is like Dremio's role in the bigger picture is to make data lakes easy. Okay, so bottom line is like whatever your challenge currently is with a data lake, generally Dremio has some sort of use case that addresses that. Like for example, if your issue is like, oh, I want to migrate to the cloud, problem is like my users are used to one tool set and we're going to end up having to switch to, like, let's say using AWS Athena, and my consumers aren't used to this. So like that's going to be a really friction filled change. Well, with Dremio, you could first set up Dremio on-prem. It connects to your on-prem sources, and then over time you start adding your data onto the cloud, and your users never notice a difference because they're using the same interface while it was on-prem and while it's in the cloud. So it makes things like cloud migration much easier. Working with Iceberg, I can't think of a platform that makes working with Iceberg more easier than Dremio does right now. Um, and again, the openness and the ability, like literally you can use either service, the catalog or the engine, and again, what data you want to have bring in, you can bring in. What tools you want to use against your data, go for it. And again, lots of the other really cool bells and whistles there, but bottom line, like there's a different mantra where like, I would say like Databricks is more like, hey, we want to be everything to everyone in one package, and say basically be the data warehouse on the data lake. So it's just a sort of different mantra, and it just depends on sort of like your use cases and sort of like, um, me personally, and again, of course, an employee at Dremio, so take that into consideration. But I mean, bottom line is like I do really honestly like believe in the whole idea of like openness and the idea like you want, like I want prices to always be like less for everybody, because I mean right now data stuff is expensive. So you want a world where you have openness, because that creates not competition just for like, so if you're on Dremio, Dremio basically creates an environment for its own competition that's going to keep Dremio's prices in check, and it's going to keep all of its competitors' price in check. And I think that's a better world for everybody, because you are going to get more innovation and better costs. So um, that's my 2 cents. But at the end of the day, like far as like performance and things like that, there's going to be a lot of factors, like what table format you're using, what clusters you're using, and it's not something that you can just compare apples to apples, because like the different clusters and the way they're shaped and used between both platforms are different. So you really have to take like your use case and actually like see, okay, what try out your use case and try to find the best approximation of they're similar. Like, and that's always the problem when you see like a lot of benchmarks for a lot of these things, is that it's really hard to do apples to apples comparisons. Um, I wouldn't say, but at the end of the day, it's also about sort of like what you think is the long term trajectory of where do you want to be in the long run, as far as like, do you plan to be like the one vendor person for a long time, or do you want to have flexibility and have sort of like some freedom? And I think that's an important consideration. So that's my answer there.
That was a comprehensive answer, yes. And I'd say that, yeah, I think you hit it on the head though. It's really hard to make an apple-apple comparison with these things. Like I think Databricks generally gets lumped into the ML ops environment. I think this is
Mhm.
kind of a bit of a debt that we have in this community, that when we were umbrellaed under data science writ large, I think a lot of the nuance of what went into data practices got kind of lumped in and merged between different practice sets. So data engineering was kind of merged underneath bigger software engineering, data architecture, information technology management, data science practices. So I think we're just now seeing companies really respecializing themselves and retooling to represent the different aspects of these
Mhm.
environments. So I think the open data lake Lakehouse is definitely one of those things that's going to catch on because it is leveraging some of the best practices out there in the community, uh, to include leveraging the deep expertise in the socio-technical spaces that are involved in producing these open projects from the get-go, and then merging those into larger comprehensive ensemble approaches to doing data architectures, data engineering practices, make that much more richer space to do what you, Alex, mentioned earlier, which is innovate.
Mm-hmm.
You know, you're going to see a lot more innovation because you have those cross pollinations of ideas and approaches and formatting, and you start seeing these hybrid approaches that really weed out the weaker practices and actually optimize for accelerating those practices that are best for certain application areas over time. So that's why I kind of love the open source slash lakehouse approach as compared to the more traditional cloud-based or hybrid or on-prem data warehouse approaches. It seems like those things are really seeing their limitations now, and people are really seeking for new solutions to scalable data problems. So it's always good to see those things.
100%. I 100% agree with everything you just said. That was wonderful. Yeah, yeah.
And Mike, to your question about speakers, Alex just joined the data engineering group. So if you want to DM on Meetup or you want to hit him up on Twitter, um, I'll post Alex's handle on Twitter here so y'all can follow him and catch up with him on there as well. So whenever he's not speaking at these events, you all can definitely catch up on what he's doing both personally and with Dremio. So it'll definitely keep you in the know, so to speak.
Yes, and I post fairly regularly on LinkedIn and on Twitter. So yeah, if you follow me, you'll definitely I'll be around. I'll be quite visible.
On my personal side of things, anytime someone mentions DuckDB, I have like a little heartbeat goes up. I love seeing that project promoted. I think a lot of people have been recently doing the DuckDB versus SQLite kind of comparisons, which in one part isn't fair because SQLite's been around for so long, embedded in so many different projects, but DuckDB has just become so popular so quickly, and I think it's got a lot of advantages that a lot of other smaller database systems would be looking to leverage. So I always love hearing that mentioned. Um,
Yeah, yeah.
also, also the flight and what you guys did with the ODBC and
Mm.
JDBC support, that's phenomenal. I didn't even know about that, but I will definitely be using that moving forward.
Yeah, I know it's great. When I first heard about that, I'm like, that is cool because I remember so many not fun evenings configuring ODBC drivers. So I was just like, that's
Yeah.
wonderful. Yeah, no, I mean that whole project is just like exciting. Like there's so many cool things going on in the whole aerospace.
Mhm.
So that's one reason I'm pretty heartened by like the popularity of DuckDB because it really shows the power of Arrow, and I think that makes projects that use Arrow it's gonna people are going to really see the value in that much more going forward.
Well, and plus I loved your stack too, like you initially presented up front. I mean, you have all the best things. You have Arrow, you have Parquet, you have Iceberg, you have Nessie, and and if everybody's still listening hasn't seen the previous discussion on Iceberg, that's when I literally first heard about Nessie in your previous discussion,
Mm-hmm.
Alex, on Iceberg, and I was like, I've been stoked on it ever since. So,
Yeah. Oh yeah, we just actually rolled out we just like 'cause right now the Dremio Arctic, which is based on SE, that service has been in preview since earlier in the year. We just rolled out like a whole sort of updated UI, and the experience is so smooth and pleasant and like easy right now. Like it's I'm really excited for like the future of it because it's like so easy to use and I just literally like just merge, do some transactions, or I mean, create a branch, do some transactions, and merge it, and you can on the UI see all the commits laid out. It's just really incredibly easy, which is really nice. Like you could just make a mistake and literally just one command you've rolled back to a previous commit, and what you've done is undone.
well, I also like the fact that it enforces I say data's code is just
Mm-hmm.
increasingly becoming pervasive in data practices. And I like seeing applications that really enforce that in a constructive manner. And Nessie definitely takes best practices from all those things, plus leaves it open to CI/CD practices and a lot of
Mm-hmm.
additional other data ops type practices that are becoming more and more critical as organizations and their data assets scale. So it's yeah, like I said, I've been trying to find ways to wiggle it into both my customer discussions and my own personal application spaces.
Oh no,
So
I agree. Like I'm just like yeah, like it's one of those like things where it definitely like tickles like that like sort of like this is a really cool innovation piece of my brain. So I always like to just like talk about it more just because it's like out of all the open source project is the one that's like that's neat. But yeah. So I totally feel the same way.
But okay, so I did have one question I
Mm-hmm.
think that I would be cool to see expanded on in future presentations
Mm-hmm.
on this topic would be, so let's say you're going into an organization and you mentioned this a little bit up front. Like some organizations are ready to be greenfielded. They have no data infrastructure whatsoever and they're looking for the solution to hit the ground running with. Or they might have some legacy systems that's a mix of commercial off the shelf and open source, or they might just have a proprietary system. Do you have a certain like heuristic or set of like staged rules to help someone kind of work through like exactly how they start migrating over to this open lake house paradigm?
I mean, I would probably say like you probably get a more robust answer probably from the essays. But yeah, no, I mean there's definitely a playbook for that, and there's definitely a lot of situations depending on sort of where people are, as far as like what are the best ways. Like Dremio is definitely very much built to be something that people can like incrementally adopt. So it's not like something like, oh, okay, I have to go toss out everything I have today so I can use Dremio. Like you could literally just say, okay, hey, I'm going to use Dremio for this one specific use case, so I can offload like a handful of expensive ad hoc queries that are running too slow, and then expand from there if you like it. Or some people don't even like use it for querying. Like they'll just use it as their access layer. Like they'll just say, okay, hey, I'm gonna just connect all my data sources and put all my rules for who can access what, and then just use Dremio as the way that people see all the data on the lake. But the data is still in Postgres. The data is still in some of it's in S3. It's just all over the place. But it's just they use it as just a way to kind of bundle the data for access purposes. Like it satisfies a lot of possible use cases. Which is always which is like a blessing and a curse because then when you try to like tell people like why Dremio, it's like it depends. What's your problem? But if whatever your problem is, we probably got an answer.
No, and I think that that really is kind of butts up against the second question is
Yeah.
like, well, when it comes to like if a company settles on like say yes we want
Mhm.
like these open source solutions and we want this lakehouse approach and we're going to use Dremio as this layer or whatever umbrella layer they want to use in terms of access. They might then ask like, okay, well, how do we approach doing either in-house or outsourcing or certain types of employment practices? Like, who do we go to? Like, is there a certain you know playbook or idea that you have in your head about how organizations personnel-wise, in terms of the data engineering technical expertise, how should first approach a company like Dremio, and then eventually doing handoff to people that are going to be those both liaisons internal to an organization, or be kind of also your advocates as well, for making sure these things are not just implementable but sustainable over time.
Got it. That's a question I need to go. I'll go have a chat with like a lot of RSAs who handle a lot of the implementations with clients and see kind of like what their thoughts are on that. Because they're gonna have more like front lines experience with the actual implementations. So I'll try to see if I can come back next time I come back to kind of give a little bit more insight into that. Like I have some dirty thoughts, but I don't have like thoughts that are like I would say refined enough to give you an answer now.
Oh yeah, I mean this
Yeah.
is a pretty common question that I run to myself.
Mm.
It's like when you come to a customer with a solution, and that's like I think you should go with these components on your database layer and these ones on your access layer, and trying to like this data architecture that it kind of meets the requirements, but also helps them sustain those utilities over time.
Mhm.
But that also requires them to commit certain personnel for either in-house training, or they need to hire somebody to help manage that, or they need to outsource that to a third-party vendor to help them contractually manage that over time. And usually they don't enter into that calculus initially when they're considering this kind of like larger data migration. So it's definitely something that I always consider when I'm thinking like, oh, okay, this is it's a great OpenStack solution, it has all this high speed potential, but if you don't have that person that's going to be constantly talking with middle management or leadership about
Mhm.
these types of things, these things can fall off very quickly, especially in like government spaces,
Mhm.
defense. Private sector is a little more flexible and a little more agile when it comes to that, but definitely in the public sector, I've seen where these things need persistent advocacy for years
Mhm.
sometimes to make sure they persist as an application layer that can actually be used and leveraged and migrated from. eventually over time within and between organizations. So it's always one of those things where I think it's an interesting question to add to that socio-technical consideration for actually building these systems up front.
Yeah, no, 100% agreed. 100% agreed. Like, yeah, no, I'm definitely gonna be up tonight about that.
Oh no, I didn't mean to do that, dude. I'm sorry.
No, no, no. It's all good. It's all good. It's all good. I'm always up all night, thinking about something. So, but
No,
that's
well, yeah,
at least it's a good question.
Krishna, that looks great. Any gotchas you've seen in your experience with this stack from Krishna?
Um, I mean, I like a lot of these technology, like especially like Project Nessie is pretty new. Like again, like the most practical application of it right now is the Dremio Arctic service, and that's currently in preview. So it's basically a thing a lot of some companies are like testing out. And when it's in GA, we'll see what it looks like when it's in more larger scale production use. But basically, it's I think always like just more the trouble is like um what exists. So like a lot like when I say from a perspective of like from Dremio's perspective, like a lot of customers they're not necessarily exactly like that perfect picture of what I had in the beginning. Like if I was starting with like a green field or just like fresh thatch, like that's what I would recommend. Like that's what I think is ideal. But oftentimes like we'll have clients who are like they are querying the like Delta Lake tables. They are or doing it straight from an OLTP database or they want to implement the data mesh so they could use like our space feature to kind of help create spaces for each of their departments and give access to the people who are going to be the people creating that data product. So a lot of times like each customer is going to have sort of like the workflows that it, and we try not to like change necessarily how people do things. We just want to make it easier for you to do the things you're already doing and at a lower cost. So we definitely, for those who need advice, we have advice, but oftentimes, more importantly, we just want to help people do what they're doing better. But as far as like gotchas, I mean, one interesting like um, situation. I don't want to say like it's a gotcha, but like what happened was like we wanted like there was one customer that wanted to use Iceberg more, but they use like Databricks for like a lot of their ETL. And one thing is that like Iceberg has like their own custom version of Spark that runs on like their clusters. So what happens like the merge into statement is like basically they reserved it purely for Delta Lake, so you can't use it with anything other than Delta Lake. So if you set up Iceberg, which is doable, you can actually like configure it so Iceberg will work. But the problem is you won't be able to run like those merge into statements because they reserved it purely for Delta Lake. So that was like a when you go set it all up and then you do it and you're like, oh, I didn't expect that. That would be one sort of like gotcha that like specific, but again, that's more specifically just like if you're using specifically the Databricks Spark and you're trying to use it with Iceberg. Um, but aside from that, like I would just say like most tools do what they say they're gonna do. It's just like at the end of the day, like there's just so many tools out there and there's a lot of data out there. And the thing is that there's so many other things to be really focusing on, like data quality, that I would say like we just focus on trying to make it easier so you can focus on spend more time thinking about those things instead of thinking about like the foundational technical aspects and focus on those higher level or deeper level aspects of how do I make sure the data is always perfect.
I will say on my part that one gotcha I've experienced with doing any kind of open
Mm.
source implementation of a system is failing to sell it to non-technical leadership first.
Yes. Yes. Yeah, you gotta get yeah. Like so that's always the fun part. Like having like to see like who's your audience. So it's like today like like there's those times where like I'll be talking about like a technology and basically I really need to like emphasize the efficacy of how if it's minute architecture versus sort of like the high level like oh you're gonna save money and you're gonna save time and kind of and sometimes you guess wrong which audience that is but no I totally understand and also like which one should you approach first yeah so I can understand that.
No, because yeah, I found that like I've had a lot of bosses that have really helped me grow that ability. It's like you have to give them the value proposition. And I think that's something your presentation did really well today. It's like up front, you already had like the pros cons. I think that's something that non-technical leaders like fixate on. It's like, okay, I now see the contrast and I now see the value proposition of moving to this new thing. So yeah, it could be as
Yeah,
simple as that.
Oh no, yeah, I agree. I always try to get that out of the way up front. I want to make sure that people know why they should stick around, because I'm always, I always got that paranoia that everyone's just going to like abandon me. So I got to make sure I remind everybody why they should stick around a little bit longer.
Well, it's also the appeal to want to talk to your audience. It's like we're
Mhm.
all engineers and we all want to build cool stuff, so it's really easy to just jump right into the technical discussion of like, oh yeah, this is why Parquet is what it is, and this is where you should use it versus where you shouldn't. And it's like, oh yeah, like someone may not know what Parquet is. It's
Ye-
like,
yes, yes. Oh yeah, I've definitely done that. I've definitely had conversations where I, I, I assumed I assumed they knew what I knew. I mean, one of the things that definitely helped me with that is like once upon a time I used to train people in finance, and after years of doing that, like you get into the habit of just learning to assume that anyone you're talking to doesn't know anything that you're about to say. So just kind of like always just making that effort to like as you talk to define the things, all the new words you bring in as you go. And I think that's definitely been been a valuable experience since for all the things that I've done.
yes, I've also worked finance. That is a challenge in and of itself.
Agreed.
Cool. Anybody else have any other questions for Alex? Going in five, four, three, two, one. All right, folks. I think we've harassed Alex enough